In this episode, we are going to look at linear first order ordinary differential equations. Now, why this content or why this topic so crucial? Now, the reason why this part of the differential equation is so important is that most times it contains the integrating factor, right? Which contains only one variable, right? Which is the x, the independent variable x, or t in terms of dependent problems, right? And secondly, the integrating factor, which is the I of x, is obtained by the coefficient of y, right? Now, let's look at how we can get those items that I'm mentioning, that the integrating factor. Now, the standard form of the linear first order differential equation is given by dy dx plus p of x y is equal to q of x, right? So this is the standard form for the first order linear differential equation. So the coefficient of y here is the integrating factor, right? So the integrating factor, the coefficient over here is the integrating factor, which is the p of x. Now, how do we get the integrating factor, which is the I of x? Now, the I of x is obtained by the exponent of the integral of the p of x, right? Dx, right? So that is how we obtain the integrating factor, or the mu of x. Sometimes we call it that. Now, the second aspect that is crucial for you to know is the left hand side of the differential equation. Now, what do I mean by the left hand side? If the equation is in the standard form, the left hand side is normally simplified, right, as dx times the integrating factor times y, right? Why? Why do we do this? We do this simplification so that we can handle the integration so easily. When you multiply the integrating factor by this standard form of the equation, you get what we call the product rule, the reverse of the product rule, right? So in the course of that, we intend to simplify that to form this. So now, let's take a problem and look at how we can tackle it. So the problem we have here is dy dx sine x plus 2y cos x, and that is equal to 4 sine squared x cos x, right? So this problem you have right here, we want to solve this differential equation, right? So in this instant, we have to form, or we have to change this equation to the standard form of the linear differential equation. So here we divide by sine x by sine x and by sine x, right? So this takes of this, and then we have dy dx plus 2y cos x over sine x, and that should be equal to, this takes one of this, so we have sine x cos x, right? So this right here, this right here, we can say that this is the same as 2 cos x over sine x, all multiplied by y. That should be equal to 4 sine x cos x, right? So this right here, now we have the coefficient of y. So what do? The coefficient of y here is equal to 2 cos x over sine x, right? So once we have this, then we can go ahead and find our integrating factor. So our integrating factor is equal to e power the integral of p of x, which is 2 cos x over sine x dx. This right here, if you don't know the integral of cos x over sine x, which is ln sine x, you can go this way, right? So let me break it down. Let u equals sine x, right? If u equals sine x, then differentiating both sides, we are going to have differential of sine x is of course cos x dx, right? So we need the x, so the x is equal to du over cos x, right? So once we have this, then we can go and do substitution. So we have I of x, which is the integrating factor, equals e power integral of 2 cos x over, now sine x, we said it should be u. So we have u right here times the x is du over cos x. So we have du over cos x, right? So this takes of this, and then we have I of x equals e power integral of 2 times 1 on u du, right? So we can say that I of x is equal to e power 2 out the integral of 1 on u du, right? So we have our integrating factor to be equal to e power 2, the integral of 1 on u is ln x, right? So we have our I of x to be equal to e power 2 in x. But in this, when you apply the logarithmic function, right, the logarithmic properties, we know that this is the same as e power ln x. Of course, e power ln u, right? Because we said that u should be equal to sine x, right? So we have ln sine x, right? So we have I of x is equal to e power ln sine squared x, right? So bringing this down, we have I of x is equal to sine squared x ln e, right? So we have the I of x is equal to sine squared x, because we know that ln e is equal to 1. So we have our integrating factor to be sine squared x. So once we have this, then we can go ahead and multiply this by the standard form of the equation, right? So we multiply I of x by the standard form of the equation, which is dy dx plus 2 cos x over sine x multiplied by y should be equal to sine 4 sine x cos x, right? So this we have right here. We can now bring the value or what we had for the integrating factor. So here we have our I of x, which is the integrating factor, is sine squared x into dy dx plus 2 cos x over sine x y, right? And that should be equal to 4 sine squared x times sine x is going to sine cube x cos x, right? So this side, we simplified this side to make it simpler for us to integrate, right? So simplifying this side, we can rewrite this as d dx times the integrating factor, which is sine squared x times y, right? And that should be equal to 4 sine cube x cos x, right? So the simplified form for this left-hand side is this, right? So once we have this, we can go ahead and integrate both sides, right? So here, before we can integrate both sides, we have to send the dx to this side. So we have d into sine squared x multiplied by y should be equal to 4 sine cube x cos x multiplied by dx, right? So integrating both sides, this takes off this, and then we have sine squared x multiplied by y, and that should be equal to the integral of 4 sine cube x cos x dx, right? But we know that before we can do this, we have to apply what we call the U-sub or the U substitution, right? So when we do that, when we apply the U substitution, we can say that we should let U equals sine x, right? So differentiating both sides, we have du is equal to cos x dx. So this implies that dx is equal to du on cos x, right? So now we can go and do substitution right here. So we have y sine squared x is equal to the integral of 4 times, now sine is what? U. So we have u power 3 times cos x, and our dx now is du on cos x, right? So this takes of this, and then we have y sine squared x is equal to 4, the integral of u power 3 du, right? So now we can integrate this so easily. So we have y sine squared x is equal to the integral of u cubed, right? You're going to have u power 4 over 4 plus your constant of integration. But we know that this will take off this, right? So we have y sine squared x is equal to u power 4 plus c. But earlier on, we said that the u should be equal to sine x, right? So we have y sine squared x is equal to sine power 4 x plus c, right? So in our interest of looking for y, we divide both sides by sine squared x, sine squared x. So this takes of this, and then we finally have y equals sine power 4 over sine squared x plus sine over sine squared x, right? This will finally have, this will take 2 of this, right? So we have sine squared x right here plus c over sine squared x, right? So this becomes our general solution for this particular problem, right? This becomes our general solution for the problem given. Now, we have been given initials. We have been given initials. We have been given initials to be y of pi on 6 is equal to 17 on 4, right? So this means that our y is equal to 17 on 4 and our x is equal to pi on 6, right? So doing that substitution to find c, we have 17 on 4 is equal to sine into pi on 6 all squared plus 1 c over sine into pi on 6 all squared, right? Right here we know that this will be equal to sine pi on 6 is sine 30, and we know that sine 30 is half. Half squared is going to give us 1 on 4 plus c on 1 on 4, right? So we have 17 on 4 is equal to 1 on 4 plus this, we have 4c, right? So we can say that we have this comes here, we have 4 equals 4c. So we have c equals 1, right? So once we have c equals 1, we can substitute into the general solution and obtain our particular solution. So right here, when we do that substitution, then we have y equals sine squared x plus our c now is 1 over sine squared x over sine squared x. Don't forget to press on the notification bell and I'll provide you with more content. Bye bye.